Hi everyone and welcome to this video. This is based on the exercise in the book called Miscellaneous Exercises, but in my opinion it should be called Integration by Recognition, as that's the process that we're going to be applying here. Now these questions are all of a fairly similar form. They always start off saying find the derivative of something and hence find the antiderivative of something else. So this is very typical questions here. And one of my personal favourites. Find the derivative of y equals log e of cos 2x, and hence find an antiderivative of tan x. So, to start off a question like this, it says find the derivative of this. So that's the first thing that we need to do. Okay, so I'm going to go dy dx equals, now, the log function, when we differentiate that, we do the derivative of the inner function divided by the inner function itself. And it's going to have to be something that you really think about here, like you have to be very careful not to get the differentiation and the anti-differentiation of trig functions confused. But when we here I am getting it confused. when you differentiate cos, you get negative sign. So that's going to be negative 2 sine 2x, remembering to write the derivative of that inner function at the front. That's divided by the inner function here itself, which is just cos 2x. So we have sine 2x divided by cos 2x, which that's just going to be equal to negative 2 tan 2x. Now that's pretty handy, okay? That's looking close to what we have right here, but it's not quite what we want. So this is what integration by recognition is, okay? We have differentiated this original function here, and we have arrived at this answer here. Now what that means is that when we anti-differentiate this here, it's going to turn it back into the original function. So what I can conclude is that the antiderivative of negative 2 tan 2x dx is equal to the original function that we started off with, which was log e of cos 2x. The interesting thing here, I'm going to write plus c. However, it's not actually really necessary because of the wording of this question. It says find an antiderivative. So this value here could potentially be 0. So if I wrote log e of cos 2x, it still is an antiderivative of it, which works out fine. It's just not covering us for all the general sort of situations. So I'm still going to write that plus c anyway, but you don't have to. The next thing I need to do is correct my question, because that should be tan 2x. And what I'm going to do is I'm going to just continue on from here. So I want to have just the antiderivative of tan 2x here, so I'm just going to take that negative 2 out the front of it. So it's negative 2 times the integral of tan 2x dx equals log e of cos 2x plus c. And the last step really is to divide by negative 2 on both sides. So I get the final answer, the antiderivative of tan 2x with respect to x is negative half log e of cos 2x, and then I'm going to write plus d. Okay, and I'm writing plus d because, well, this value of c has been divided by negative 2, so it's just some constant divided by negative 2, it's going to be a different constant. Okay, and I don't need to change the sign because it could be plus a negative number, which would then make it negative, and well, it's all good from there. So that's integration by recognition. These questions can sometimes take a while to work through, and I will do another example still, but yeah, follow up again in the next video. I'll see you then.